Thanks for joining this session about ProxySQL on Kubernetes. Quick introduction about myself. So my name is Rene Cannao. I am the author and CEO of ProxySQL. I started ProxySQL as a project in 2013. My background has been always on operations, so like system administration, database administration, and network administration. My focus has been mostly on database, and thus I have a strong focus on performance and reliability of SQL traffic. A quick note about what ProxySQL is. ProxySQL is a database traffic layer that basically is able to sit between the application and the database server and performs a variety of action. Currently, it supports two protocols. It is protocol aware for both PostgreSQL and MySQL. It initially was only MySQL and now is also support ProxySQL. It is able to manage the various connections, so the connection between the client and the proxy, and then all the connection between the proxy and the backend. It has a lot of features, and in this session, we're not going to cover them all, but we're just going to briefly mention some of them. And probably the most relevant in this context is about routing. So the ability of being able to route traffic according to the semantic and the meaning of the various requests. It also provides a lot of observability. So it exports a lot of metrics about what type of traffic is passing through ProxySQL itself. We're going to get into more details soon. So the topic about this session is about Postgres in Kubernetes and how ProxySQL fit in this. And specifically, Kubernetes is able to run Postgres in Kubernetes, of course. And you have various components that are able to manage the life cycle of Postgres itself. But Kubernetes itself is not SQL aware. So while it is able to manage all the application and is able to manage the backend, is not really able to understand what is the traffic that is connecting the two. This is where ProxySQL enters this scene. It's basically able to understand what is the content of the connection, understanding the traffic, and is able to route the traffic accordingly and expose all those information. So of course, in Kubernetes, you can deploy Postgres, and you can have Postgres that is absolutely healthy. And you might even have both Postgres and application that are both of them healthy. But this is where Kubernetes stops in terms of its own responsibility. So it knows that the application is healthy, database is healthy, and what is actually putting them together is the traffic. And this is where exactly ProxySQL get into play. So you have the application that has his own logic, his own pools, their workers, their mechanism, all the jobs, and so on. Then from the other hand, you have the database that you have a certain amount of capacity, and that is responsible for transaction and so on. And ProxySQL is basically the middle layer that is able to connect those two. So what might happen on production traffic in Kubernetes, but actually a bit everywhere, it doesn't matter where is the environment. So you may have some connection storms, or basically you can have a connection storms when you have an application that is being restarted, or there is scale out, automatic scale out, and you might have a lot of application that reconnect all at the same times, or just create a lot of connection. And you can also have a situation in which you have a writer overloaded. So basically, in a database deployment, you can have one writer and multiple replicas, and the writer might be the one that is absorbing the majority of the traffic just because the application is connecting to it. And specifically to Kubernetes, you might have the pods that are healthy, visible, everything is fine, but the traffic between those pods is a bit a blind spot, like you don't really know exactly what is happening. And also you might have a situation in which when application is being restarted or new application is being deployed, you have a slow response because it often required also some application redeployment. And another issue that you might have in Kubernetes, but also outside of Kubernetes, when you have a lot of application, is that every team has built its own connection and routing logic, and that works very well if your application is simple. But as soon as the application starts growing, this becomes very difficult to scale. Back to Kubernetes, you might have a situation in which you have Postgres that is very healthy, and like the database is up and running, is taking reads, but at the same time, the traffic is not healthy because you can have things like connection pressure or routing that is not done properly, or traffic is being sent to the wrong servers and so on, or you don't have any sort of back pressure and so on. So in theory, this should work very well when there is just a simple application. But again, when this scales, it becomes very difficult to handle. So back to Kubernetes, what Kubernetes is actually give you in an infrastructure like this. So Kubernetes is able to give you the various features, like it give you the scheduling, so it manage the life cycle of the pods. It also gives you the configuration, so you can have the config map, all the secrets, and so on. Also, Kubernetes give you service discovery, so the application can understand where the various services are within the deployment, and a platform API. And this is the responsibility of Kubernetes. But again, is a service, when Kubernetes give you a service like a Postgres servers, is not actually an SQL policies. So basically, you have limited information about what a writer is. You have absolutely no information what a transaction context is. So the application doesn't, like Kubernetes doesn't really know when a transaction starts and when a transaction ends. Similar things, like you have no idea when there is a replication lags and so on. So Kubernetes just give you the infrastructure, but all the details about the SQL policies are not there. What about operators? Well, the operators, when operating within Kubernetes, are able to provision the clusters. It also provides some sort of topology, so you know which one is the primary and which are the replica. Also, the operators also give you some failover orchestration, so it ensures that the primary is always up. If for whatever reason the primary goes down, the operator can perform a failover, etc., etc. The operator also take care of the life cycle of your Postgres cluster, and again, it takes care of the various component of a Postgres cluster, but again, it's not SQL aware. So the traffic is where actually ProxySQL is what is going to take care of. So what about the traffic layer? So basically, ProxySQL try to address the missing capability that orchestrator and the operator doesn't provide. So what happened when there is a redeploy? What happened when traffic need to be redirected from one server to another one? Or what happened when certain type of we need to perform certain type of operation on the traffic, like identify which one is the writer, which one is the reader, and send traffic only to those specific servers. Can the application connect directly to the database server? Well, yes, that might work reasonably well if the application is extremely simple. So like if you have just one application and probably just one database server. But as soon as things start scaling out, this a direct connection doesn't work anymore. The reason is simple, because if you have just one application and one database server, basically all the routing and all the decision making is in the application. And of course, the more the application becomes complex, it becomes more difficult to have all those logic directly in the application server. So for instance, you might have an application that, or multiple application that is scattered and have different logics. So like you can have different type of timeout, you can have a writer endpoint, you can have reader endpoint, you can have different failover logic, logging, and so on. And having all those those criteria built in the application makes very difficult to scale, because you end up in a situation in which each team should manage their own logic and their own criteria. Instead, what you can have is a shared traffic layer that is basically what ProxySQL provide, in which the application will have just one stable endpoint, and the endpoint is provided by Kubernetes itself. And beyond this specific endpoint, you will have basically ProxySQL that will become the responsible for managing the traffic. How does it do this? So basically, ProxySQL internally has a series of host group, and where each host group is nothing more than a series of one or more database server that has one specific logical functionality. And you also have rules that define how the traffic need to be routed to those nodes and what other sort of transformation need to be performed to that specific traffic. And of course, all this is extremely configurable, and you also have all the details and all of the observability. And the other interesting things here is that you can basically reconfigure everything at runtime without the need to perform any restart. So again, the application, the great things here is that the application doesn't need to know anymore about the whole infrastructure. So it doesn't need to know about all the Postgres servers. It only need to know just one simple endpoint, and the application just connect to it. And behind the scene is where ProxySQL will manage all the traffic. So from an application point of view, it's just one single endpoint, and that's it. Simple. And the application will connect to ProxySQL. ProxySQL will apply rules to the traffic sent by the application, and ProxySQL will decide based on those rules to which Postgres server need to be sent those traffic, and in which measures, like how many connection, if traffic need to be throttled, if traffic need to be routed to multiple servers, and so on. So at the high level, this is how the layers looks like. So you have Kubernetes that is able to deploy the application, and also Kubernetes will provide a service for ProxySQL. ProxySQL will be deployed in some pods, so the application will connect to the pod where ProxySQL is running through the Kubernetes service. And also Kubernetes will take care through the Postgres operator to deploy the various Postgres server. And on the other hand, you will have ProxySQL that is able to direct traffic to either the writer service or the reader service. This scheme is extremely simplistic because, just to put them in a slide, but in reality, you can have one ProxySQL instance or ProxySQL service in this case that is able to handle not just one Postgres service, but you can have hundreds of Postgres server behind one single ProxySQL service. So, what ProxySQL provide in this sort of architecture? Well, first of all, is protocol aware, so is able to understand the traffic. So this is extremely important because this means that there is not anymore a one-to-one connection between an application connection and a backend connection, but because it is protocol aware, it is able to understand the boundaries of queries. It is able to understand the query itself. It is able to understand when a backend connection can be shared. It is able to understand when there is a transaction, and so on. So it is able to get into the details of the traffic. So it's not just seeing the traffic, but it understands it with extreme details. So it's able to manage all those connections. Also, because it's able to understand all the queries, it can match those queries with certain rules that are configurable, and based on those rules is able to route the traffic to certain host group or apply other criteria, like it can cache some result set, or it can even block certain type of traffic. So, if, for example, you deploy some application that is trying to access some data that was not supposed to access, or the application is misbehaving, you can also block this sort of traffic. Also, as I mentioned briefly previously, all the actions that are being performed by ProxySQL are extremely visible because ProxySQL export all those information. So in real time, you can always identify what traffic is passing through ProxySQL and take action based on this. What ProxySQL is not. So it is very important to understand ProxySQL is not an operator. So itself, it doesn't take care of the management of the PostgreSQL life cycle. So it doesn't take care of things like it doesn't perform any failover, it doesn't perform any backup. If you need to start a new Postgres server, it's not ProxySQL that will take care of this. For all those actions, you need the operator. And also, if it is not responsible for the correctness of the data on Postgres. So, if you have replication, this is always something that you need to take care at database layer. So it's not a responsibility of the proxies. Also, when it comes to read-write split, it is also very important that ProxySQL is configured correctly. So ProxySQL does not just blindly performs read-write split, is perform read-write split based on some rules that you as the DBA have configured. So it is extremely important that those rules are configured correctly. So in this slide, we are basically describing what are the responsibility of the various component. So far, we basically discussed about Kubernetes, Postgres operator, Postgres itself, and ProxySQL. So the Kubernetes is responsibility is basically of scheduling, managing the secret, and providing the services. The Postgres operator instead take care of the life cycle of the Postgres cluster. So starting Postgres server, managing all the replicas, and taking care of failovers and so on. The responsibility of the database server, in this case Postgres, is that taking care of that the correctness and the replication are fulfilled. And instead, the responsibility of ProxySQL is to perform traffic control while being SQL aware. So it's able to understand the traffic and performs the various action on the traffic. So let's get a bit more into details of what are the ProxySQL policies. So first of all, basically ProxySQL is able to understand the text of the query, if it is in a transaction, what is the users, what is the schema. So all those metadata are available to ProxySQL, and it will perform decision based on all this. It is also able to understand what is the health of the Postgres server, because it has a lot of monitoring, and thus it understands the health of the server. Is the server able to get some right? What is the pressure on the server? How many connections are running, and so on. So based on those information and all the internal rules that you have configured, it is able to perform the routing and determine the behavior of the various connection. So one of the common question that we always get is if ProxySQL is actually adding more traffic complexity. And actually the answer is no. Actually, it simplifies the the traffic management. So it actually reduces the traffic complexity, because normally what you normally have is that you have the application with its own pool, its own retry mechanism, its own detection of failover, and a lot of decisions that are implemented in the application. And so this is often get very complicated when you have multiple applications and not just one. So the idea here is that instead of all the application having each of them their own policies and their own retry mechanism, their own pools and so on, all this is shifted to the middle layer that is ProxySQL, and that it will take care of having a unified set of policies. So again, in this way, because everything is centralized, you can also export all this information and make informed decision about how to manage the traffic in the Kubernetes infrastructure. So specifically about the connection management, you can have a lot of application. Each application will have its own each application is on in its own pod and with its own pool, and you have a variety of retry mechanisms that are built inside the application. And in this way, the application doesn't need to know anymore where the Postgres server is located, because the application does not connect anymore directly with Postgres. Instead, it will connect to ProxySQL that act as a middle layer, and ProxySQL will be responsible for managing the session. So the application will connect to ProxySQL, and you might have 1,000 or hundreds of thousands of connection, and then ProxySQL will be able to understand which of those connections can be funneled into a limited number of backend connection to the Postgres server. So you might have a lot of backend connections that are being reused by multiple client connection. So here is something also very important to understand, because one of the common misconceptions is there are actually two common misconceptions. One is that each application need to have a backend connection all the time, and this is not true, because you can have multiple applications that are sharing one single backend connection, and this is actually very efficient. And another misconception is that when you perform this sort of strategy in which you have multiple clients that are using the same backend connection, somehow the backend connection is contaminated. It's like because, for instance, they might share one transaction, and of course this is not the case, because ProxySQL and all series proxy that performs something similar, they should be able to track the status of the backend connection and identify if, for instance, there is a transaction or if there is a temporary state. So there are certain criteria in which that prevent that backend connection to be shared. So you have two extremes. One extreme in which you have each client connection has a backend connection. This is absolutely wrong. It should never happen. And you also might have a misconception in which people believe is that you have multiple clients that are sharing the same backend connection at exactly the same time, and the backend connection is actually contaminated, cross-contaminated. And again, this is also not the case. ProxySQL is able to track the status of the backend connection and identify when it is safe to share the connection between multiple clients. And of course, it has a lot of logic on how to reset the connection when needed. Okay, now let's get into some classical scenarios of what might happen in Kubernetes when you are deploying an application and you're using Postgres. You might have a situation in which you have a connection storms. For example, when you have a spike in the application traffic, or you are redeploying the application. So you might have a situation in which all the application immediately create a lot of new connection. And of course, if they connect directly to Postgres, this will lead to some server performance issue, because because Postgres is not able to handle a lot of connection all at the same time. How to solve this? Again, the topic of this session is basically you can use ProxySQL. So the application will connect to ProxySQL that will handle a lot of, without serious performance issue, will handle those connection storm. And then the request will be queued inside ProxySQL, and it will prevent to overload the Postgres server. And here there is a simple matter on how, for example, you might have a situation in which you quickly overload a Postgres server if you are using direct connection. For instance, assume that you have an application that have 20 pod. Each pod has its own connection pool of just 50 connection. That's a very limited number. And if you restart all of them, that's immediately create 1,000 of connection. And if those 1,000 of connection are hitting Postgres directly, that will create some performance issues. And instead, what you can do is just connect to ProxySQL that is able to handle hundreds of thousands of connection without any serious performance issue. Okay, now let's get a bit more details into query routing. So when the application is sending traffic to ProxySQL, what we have is that ProxySQL is able to track what are the writes, what are the transactions, and is also able to understand, according to configuration, of course, what is unknown safe reads. So some reads that, for example, can be sent to replicas and so on. And also what is unknown traffic. So traffic for which it has no rules at the moment. So based on all those information, it then consult its own routing policies, and based on the routing policy, will perform some action. For instance, if some traffic is designed to be sent to the writer host group, it will send the traffic to the primary. If instead is designed to be sent to the reader host group, it's going to send them to the replica. And if it is some traffic that is unknown, probably the best thing to do is to send to the default host group that is probably the writer as well. As I was briefly mentioned before, and I'm going to repeat here now, in ProxySQL, we have the concept of host group. That, again, host group is nothing more than one or more server that has the same logical functionality. So here, a writer host group, it means one primary. But the reader host group could be the set of replicas. So you never configure a traffic to be sent to a specific server. You configure traffic to be sent to a host group that is one or more servers that has the same logical functionality. Of course, not all destinations are equals. So you can have, for instance, one destination host group that is the writer. So on the writer, you send all the writes, of course, and all the reads that absolutely need to be in sync. But also you can have also replicas. Those are replicas where you want to send the reads in which you might accept some small replication lag. Or if you have some very heavy or long-running reads, you might want to send them to some reporting server. And again, in the concept of ProxySQL, where every server belongs to a host group, you might also have a host group in which you want to not send any sort of traffic. So basically, those are servers that are temporarily disabled because, for instance, you are performing some maintenance. To iterate on this, the host group is nothing more than it's a routing contract. It's basically not just one single server, but a set of servers that performs some logical functionality. Okay. So how does it looks this from a practical point of view? So what the application sees is just one ProxySQL endpoint. So the application just connects to it. The application doesn't need to know about which one is the primary, which are the replicas. From the application point of view, there is just one single endpoint. The application doesn't even need to know if there is one Postgres cluster or if there are hundreds of Postgres cluster. The application just need to know one stable endpoint. So this means that the application will only have a connection to it. So the connection string will be extremely simple. And often the application doesn't need to have any complex logic when it comes to retry mechanism and so on, because this is all implemented by ProxySQL. And ProxySQL internally will determine how to route the traffic to the right host group and the right servers. Okay, now let's fix a bit more of read file split, because this is something quite common. Like you might want to use ProxySQL to split the traffic between multiple servers in which you want to send some traffic to the writer and some other traffic to the reader. By default, what we always suggest is to always start sending all the traffic to the writer. This should be the default. And because ProxySQL export in real-time statistics, you're able to identify what you might be consider traffic that is safe to be sent to the replicas. So based on the information that are available, you can create some rules, and those rules says, okay, now you have this limited set of queries or free queries that you can send to a different servers or a different host group, the reader host group. So again, by default, send everything to the writer and identify what can be sent to the various replicas. Here, these are very simple diagrams of what need to be sent to the writer. So for instance, to the writer, you might also send not only the writes, but also some specific set of reads, like all the select for updates or the reads that are within a transaction. This is by default, so you don't need to make any change here. By default, ProxySQL sends all the reads within a transaction to the same writer. And if you identify that you have some specific queries that need to be sent that cannot accept any sort of replication lag, you send them to the writer. But at the same time, if you identify some queries that are okay to be sent to a replica, you can easily create some rules, and those select statement will be sent to the right replica. Here there is, just a small diagram that describe how the routing policy should be in general. So unknown traffic, traffic that you never manage to tag properly. So the default will be that everything should be sent to the writer. Same things for transaction. So the transaction should go to the writer. And if you identify that there are certain queries that are safe to be sent to the replica, you can just tag them and create rules to send those queries to the replica. Long-running queries that are long-running select statement like analytics can be sent to a different set of replicas that are specific for analytics. And then ProxySQL also provide a lot of metrics and troubleshooting and logging capabilities. So you can enable all this, and in real time, you can get all those information. Okay. As I was mentioning earlier, it is very important that whatever you are not sure if it is safe to be sent to a replica is always sent to the writer. So you ensure that you have correct data when those queries are being executed. And again, it's very important to understand that ProxySQL is always able to provide a lot of auditing, so you have a lot of extensive logging and information, so always you are able to understand how the traffic is being routed through ProxySQL. So when you actually configure in ProxySQL, this is a very simple example on how query rules works. So in ProxySQL, the routing is configured through a tables. So it's a tables with a lot of columns that you can define exactly certain criteria for matching the traffic. So in this case, what we are in this example, we are defining some query pattern. So for instance, we are defining that all the select for update need to be sent to host group 10, while all the other select statement are being sent to host group 10. And then we create yet another rules that says everything else goes to host group 10. So this is a very basic example of how to configure routing inside ProxySQL. The table is called PGSQL query rules. That is mimic also the counterparty MySQL tables, that is MySQL query rules. Okay, next. All those information, so like every time you are running queries, ProxySQL is collecting statistic in real time, and all those statistics are exported also through tables. So you have tables like stat PGSQL connection pool, in which you can see in real time how many connections are being used, how many connections are being free, etc. And then you also have other tables like the stat PGSQL query digest, in which in real time you are able to identify all the queries that are being executed through ProxySQL. So you can, for instance, order them by execution time or by count. So you are able to understand which are the queries that are most common. Okay, so let's sum up, and we are basically have the Kubernetes that is responsible for providing pods, services, restart, and managing all the hardware resources. On the other hand, you have Postgres that is responsible for the database itself, so for managing the data. And in the middle, you have ProxySQL that is able to manage the traffic between the application and Postgres. ProxySQL is basically taking care of managing the traffic between the various components, but it is not just a way of providing better performance and managing spikes, connection spikes, and so on. This is absolutely part of his task, but it's not just this. It's also very important to, it's also very useful during incident. Like for instance, if you have a situation in which one database server goes down, ProxySQL is able to hold the traffic until a new servers come back online. But is also can be also useful, for example, to throttle traffic, or for instance, it might be used to block a specific type of traffic. So if you have if you're under attack, for instance, you can determine that certain type of traffic need to be blocked. Or if you have an abusive application, you can identify this application through ProxySQL, and ProxySQL can either throttle or block a specific type of traffic. And again, this is done through all the series of rules that ProxySQL is able to provide. So it is able to provide a connection of, managing of the backend connection, but also the managing of the traffic. SQL is able to provide real-time information about all the traffic that is passing through ProxySQL itself in real time. This means that in real time, you're able to understand the traffic and create policies based on the traffic that is, all the statistic that is being exported at the moment. So if you're in a situation in which you need to reconfigure ProxySQL, you can do this absolutely in real time without need to redeploy or to change configuration file and so on, because this is done in real time. So you can observe what is actually happening, and based on those observations, you can perform some reconfiguration. And this becomes extremely important when you are handling real-time traffic, because you can quickly identify if there is the need for to perform some maintenance, like if you have a replica that is not operating correctly, or if you identify if there is a bad query pattern. So like an application that is sending some incorrect type of queries, or an abusive query, like a query that is being executed a large number of times. So you can identify this in real time and perform some action. Same things also when it comes to writer pressure. For example, if you are saying that the application is sending way too many writes all at once and is hitting hard on the writer, you can implement a lot of logic there. For example, you can limit the number of parallelism that you can have when hitting the writers, or you can artificially delay certain type of queries as a way of throttling and so on. So all this can be done in real time. Similarly, if you have also failover scenarios, ProxySQL is able to detect this in real time, and it might slow down or even stop new traffic until the failover has completed. So once the failover has completed, then ProxySQL will resume sending traffic to the right server, in this case to the newly promoted primary. So that's great, both during real-time operation, but also during incidents. So during an incident, you're able to identify if you need to perform any sort of operation to the traffic. Like, for instance, if you want to remove a server from a host group, or you want to perform some maintenance, you might, for instance, decide to drain all the connection before removing the server in production. So all those things can be done in real time without need for any restart and without need to perform any configuration change in some config map file. And the great things about this is that it basically removes the guesswork. So you don't have to guess what the traffic is doing because you actually have evidence. So you know in real time what is happening on the traffic. So you're able to perform some educated decision. So you know exactly what is happening, and you know exactly what is going to happen once you implement some new policies. So now let's have a concrete Kubernetes pattern. So you have an application namespace in which you have one or more, of course, application pod. Those application pod have a stable endpoint that points to a ProxySQL service. And behind this ProxySQL service, we basically have a series of ProxySQL pod, and those pods are SQL aware, and they perform some routing and send those traffic to, for instance, a Postgres writer service and a Postgres reader service. Again, the writer service might be just a service provided by Kubernetes or ProxySQL that is able to connect directly to the Postgres pod. So it really depends if you're using the service or the pod directly. Here it is how you configure ProxySQL to have connection to a Postgres server. So the Postgres servers are configured in the PGSQL server table, in which you define the host group ID, the host name, the port, and various extra configuration, like for instance, the max number of connection. In this case, in this example, we are basically configuring a Postgres writer in host group 10 and a Postgres reader in host group 20. You just configure them, inserting certain row in a table, and then you load this table to runtime. What about the configuration in Kubernetes itself? So like you can use the config map. This is one of the way. In ProxySQL specifically is not required because ProxySQL use its own configuration database, but this works well in and out of Kubernetes. Even if in Kubernetes is mostly common to have a config map, ProxySQL can use that as well. And you also use this Kubernetes to manage all the secret and the service. And again, in ProxySQL, you can do this either using the config map and the service of Kubernetes or just configuring directly through the admin interface. It is an interface to which you can connect to any client that support either the MySQL or the Postgres protocol. Because once you connect there, you are able to execute SQL statement. Also, PostgreSQL is the one performing all the health check to the Postgres services. So you have both Kubernetes that is performing the probing, so verifying that the service is up and running, and you have ProxySQL within Kubernetes that is doing the same. This is how it looks, more or less, a very simple diagram on how failures are managed within Kubernetes. So you have a Postgres operator that is responsible for the Postgres SQL cluster. So he's able to identify which one is the writer, and if for whatever reason the writer become unhealthy, you have the Postgres operator that will be responsible for performing the failover. On the other hand, you will have ProxySQL that is regularly performing some monitoring check on the Postgres cluster. So ProxySQL will be able to understand when a failover happened and is able to determine this, and it is going to change its own routing policies to send traffic to the healthy node. So from the application's point of view, nothing has changed because the application is always connecting to the ProxySQL services. So the application does not even detect that there was a failure on the Postgres cluster. From an application point of view, what might happen is that the application might see a slight delay when executing queries. So what happened during a failover? So during a failover, as I displayed in the previous diagram, you have the operator that is detecting, which is the healthy node. It will performs the promotion, and Kubernetes will provide, eventually will provide new pod or stable service endpoint, and ProxySQL will monitor those and redirect traffic to the right node. And from the application point of view, nothing really changed because applications have stable endpoint. Great. So basically, we can now split the failover into basically two jobs. One job is the topology jobs that is done by the operator. The operator is the one that is actually performing the failover, while the other part of the job is the traffic job. This is ProxySQL responsibility. So when a failover happened, it will be responsibility of ProxySQL of redirecting the traffic to the healthy node. Those two are two different jobs, but they are quite complementary. Now, there is, unfortunately, we don't have any recent or up-to-date Helm chart for ProxySQL on Kubernetes. We are planning to change this very soon, so we are working on trying to refresh those Helm chart. But recently, we also had a blog post from Solanica and the Open Everest team that basically showed how to deploy ProxySQL on a Kubernetes managed Postgres cluster. It was a recent blog post. I highly recommend it to have a read. From our end, also, as I was mentioning before, we have an old repository for Kubernetes. We are working on remodernizing it, also because previously was only supporting MySQL and very old version of ProxySQL. So we are absolutely working on making more modern and up to date. So we will also add Postgres and also all the new features that we introduced in ProxySQL in the recent years. So of course, we are going to make sure that those are easy to use. So we are focusing on making sure that those Helm charts will work seamless with the modern operator. And yeah, I think close. So basically, we are going to update those Helm charts to make sure that they support the proper secrets, the life cycle, and the discoveries. That will make sure that they are properly modernized. So hopefully in the next few weeks, we will have more up-to-date Helm chart with that related to ProxySQL on Kubernetes. Okay. Yeah. So basically, those are all the items that we are working on, making sure that the ProxySQL is update and easy to deploy on Kubernetes infrastructure. So we will take care of all the read-write split and integration with the various operators and making sure that the observability is there and that is easy to manage. Questions? And yeah, we basically reached the end of this session.